Hello students, in this video I will be talking about the lab program 8 for the subject data structures lab, and the subject code is BCS 305. Okay, let's look at the program statement. You have to develop a menu driven program in C for the following operations on doubly linked list. Okay, and it's on employee data. The fields are SSN, name, department, designation, salary, and phone number. You have to develop a program where the operations are on doubly linked list, and the informations are SSN, name, department, designation, salary, and phone number for the employee. Okay. The operations that need to be carried out are: create a doubly linked list of n employees data by using end insertion, and display the status of doubly linked list and count the number of nodes in it. Perform insertion and deletion at the end of doubly linked list, and perform the insertion and deletion at the front of the doubly linked list, and demonstrate how this doubly linked list can be used as a double-ended queue. Okay, let's look at all of these things. See, before I start, let me talk about doubly linked list. Okay, see here, doubly linked list. See, there are nodes. Linked list is made up of nodes. Okay, let me say that the address of this is 100, this is 200, and the address of the third node is 300. And in case of doubly linked list, double, so here the nodes are divided into three parts. The nodes are divided into three parts. Okay, the first part, this part, is the one where the address is stored. This is also where the address is stored. Address. Here also address. Here also address. Here data is stored. In the middle, data part. Okay. Left and right of the data is address field, and in between we have data field. Now what does it contain? See here. This one. Okay. For example, this node, the first node, it will have two parts. The first part, that is your address, it will contain the address of the previous node. So, if you look very carefully, the first node does not have any previous node to it. That means there is no node before it. So, this will have null. Whereas, this third part, okay, it will contain the address of the next node. So, there is a next node. So, this will be 200. Are you clear? Now we'll talk about this node. We'll call that node as second node. So in the previous part, it will contain the address of the previous node. So the previous node is having the, sorry, it will be having the address 100, and this will be containing the value 300. Likewise, this particular node, node 3, its previous node's address is 200, and after that there is no other nodes, so this will be null. This will be null. This is how the linked list works. Okay, so insertion can happen at either ends. Not insertion, sorry. The addresses are stored at the either ends of the node. Okay, you can take some time and read this. So this has information about the doubly linked list, and also about the experiment. Okay, let's look at the algorithm. We will start by reading the values of and this one is not student, sorry, this should be employee. Then we create the doubly linked list. We display the status. We count the number of nodes. Perform insertion at the front, deletion from the front, insertion from the end or the rear end, and a deletion from the end of the list. And also show how the doubly linked list can be used as a double-ended queue. Then we exit. Okay, so first part is defining the node structure. See, one node, for example, this is one node, and three parts are there. So this one is previous, this one is the next, and this is your data part. Okay, suppose your node is named as temp, then the first part would be temp of previous, then this would be second part would be temp of data, and the third part is temp of next. So you have to create these three parts, define. Okay, now the thing is, in the data part, because it is an employee, if you go back to the question and see, in the employee data itself, there should be SSN, name, okay, department, designation, phone number, all these things. Okay, so here you will have different types of information. See, I have defined struct node, that is the name of the structure, and for name, I have defined a variable for name, SSN, department, designation, and phone number. Phone number is having 10 digits. So instead of having int, I have defined it using the data type long int, because long int, that is because if I use int, I might not be able to store all the 10 digits. So I have used long int. Okay. And salary, I have defined it as float. So this is your data part. Now, two pointers. One is your previous and the other one is your next. So because this will contain the address of the previous node, this will contain the address of the next node. So it is taking the data type of the node itself. So struct node star of previous, struct node star of next. Okay. And I have made use of type def again, so that I did not use this as a data type. Instead of that, I can just use node. Okay. So that is what I have done. So from now on, I will be referring to, if I have to declare a node, then I will be using the data type as node and not struct node. Okay. See here. So node, and I have defined temp, first and end. See, if I have nodes like these, okay, this one, like this addresses. See, this is a first one, right? This node is a first node, and this is your second node, as in the last node in this case. So we have a pointer called as first, which will contain the address of the first node. Likewise, we have one more called as end, which will contain the address of the last node. It's a pointer. Okay, so this one is a pointer to the first node. This one, not, it is not a pointer to the first node. It contains the address of the first node. So basically like a pointer itself. Okay, now we will create the node. See, I have again used the, like if you have gone through the video of the 7th lab program. So I've used the same function name so that it becomes easy. See, I have created a function for the node creation, that is get node. I have named the node as X, and for the data part, I have used dynamic memory allocation. So not for the this one data part, just the X node. So data type is node malloc, and I've used size of struct node. This one can be replaced by node also. Okay, and because there are three parts, sorry, because there are three parts, So while you define the x of previous, it is assigned to null, and x of next is also assigned to null, because right now there are no other nodes. So there is no previous node, there is no next node. So both are assigned to null and will return the value of x that you have just created. Okay. Now let's go to the next part. We have to read the information. So read function is called, read function is called, and we, if in order to create the node, we have used the function called as, we are calling the function called as get node, and SSN is there. Likewise, we are using the statement for name, department, designation, phone number, and salary. Okay, so we are inputting the details via or using this read function. Okay, this is for the given node. So, yeah, you can read also this one. Okay, now create. Okay, so what we are doing is, sorry, create the doubly linked list. So parameters are there. One is your, sorry, just a second. Okay. Okay. So some variables have been declared. This is because I need to use a loop, right? Because number of students might be more than one, and not number of students, number of employees. So I'm asking the user for the number of employees, and I'm making use of loop so that it can be entered. That many employee details can be entered. So while I is less than or equal to n, why I is less than or equal to n, that means if the student, sorry, if the user gives 4, then it would be I less than or equal to 4. That means um, 4 employee data can be entered. So enter the details of the employee, then read. Okay. Read function is called, and you will be asked to input the details. Next, two cases are there. While I do the insertion, what if the list is empty? See, I have to make sure that if the list is empty, then whatever node I will now try to insert or create, okay, that will become the only node in the list. So that is why, see, if the first is equal to null, first is equal to null, do you remember first? First is the pointer, it will contain the address of the very first node. So if this itself is null, that means there is no linked list altogether. So whatever you create, the temp node, okay, that only, the address of that only will be stored in the temp. Likewise, if you remember, there was one more pointer called as end, which will contain the address of the last node. Okay, now because this is the only node present, that is why this also this also will be containing the address of temp. Right now, sorry, here it should contain the address of temp. Here also it should be containing the address of temp. So if first is equal to null, that means no nodes are there. So whatever you create temp, that itself will be containing, that will itself will be stored at first and also at the end. Otherwise, okay, otherwise, see, it says end insertion. If you remember, end insertion. So this is first, and end also will be here like this. Now, I want to insert the new node over here. That means wherever the end of next, see, previously with the end was here, okay, the end was here. Let me draw it neatly to show you. Like this, I'll draw a 3 node, and this is end, and this is first. So, yeah, like this. See, now I want to insert the new node called as temp. So, what should happen? See, remember, temp will become the last node, right? Okay, so temp will become the last node. So wherever this was your end node now, right? This was your end node. So end of node, end is next part. That means this part. Ends next should contain temp. Ends next should contain temp. Also, temps previous should be containing end. You're creating that connection like this. Okay, so ends next should be containing temp. Temps previous should be containing end. And this no longer is the end. Temp will now become the new end. So these are the connections you have to make. Okay, so end of next is equal to temp. Temps previous equal to end. End is equal to temp. So go through this, read this, comments so that you are able to understand the purpose. Okay, so let me go to the next part. Now display count. Okay, that means you have to count the number of nodes. See, I am having the nodes like these. These are my nodes. This is first and pointer, and this will be containing this one's information. This is containing this one's information. Okay, now what happens is this is your first node, okay, and this is your end node. Now you see, I have also given one variable. There is no creation here, just counting, right? So the first node itself, I'll make it as a temp because I have to go from this node to this node to this node, right? That means I have to count. So I have to move the controls also. So that is why I am using this variable called as temp. Again, if the first is equal to null, that means no list is present. So employee detail is null and the count is count as in 0. So that is why I have given the count as 0. Otherwise, what happens is, see here, employee details. So these are your sort of like a header, like the heading. So SSN is their employee name department. So what I will do is, like this. So initially, if the first node is temp, okay. So when do I see? I have to move the control. That means this is my first node, this is my second node, and this is my third node, right? So every time I count, every node I count, okay. So the control has to go to the next node, next node, so that it can be counted. Right now, what I can do is this one, this first node. That means the count is 1. Next time, when I take the control from the first node to the second node, count should increase to 2. Count should increase to 2. But how do I take the control? So I'm making use of this temp. See, look very carefully. Only this one will have the value null. Correct? This one only will have the value null. And also, see, if there is data present, okay, so this one will have some data. This one will contain the address of the previous node. Okay, so what they have done is, see, when the temp, this condition I have used in order to move, in order to, give the final condition. So temp is not equal to null. See, till here, okay, what happens is, this one, okay. So here also, here the temp of next is equal to null, right? This next as in the end. So till here I have to take the control. So while temp is not equal to null, because here also it will not be equal to null, this also will not be equal to null. We are going to count. Okay. So what I'm doing is, I will use this final condition, temp is not equal to null. I increase the count by 1. That means I'm moving the control. I am basically I'm taking the control to a given node and increasing the count. So I will display, so temp of SSN, temp of name, temp of department, temp of design, and all the other details. Then I will display the employee count, return. But before that, in order to take the control to the next node, wherever temp was pointing to, temp of next, wherever it was pointing to, make that as a new temp. Follow this one so that you can go to the next node and then you do the counting. Okay, this is how you will display. So, yeah, insertion at the front. Insertion at the front. So, I'll just take two nodes. Okay, so this one will be first. One thing is, if first is equal to null, if your list is empty, then whatever you create, the temp node, that only will be pointed, that only will be having the, it will be given the address to the first, and temp itself was the only node. So end also will be containing the address of the temp. Otherwise, insertion at the front. Okay, so you have to insert the node over here in between. So what happens is, wherever, see, let me write it over here like this. This is the current node. These are the nodes that are present. Let's assume. Okay, so there is a pointer called as first and there is a pointer called as end. Okay, so like this. So this will contain the address of the first node. This will contain the address of the next node. So like this. This is how the setup is. Now, what I will do is, I will try to insert the node temp. I'll try to insert the node called as temp. Now, if you remember, this is first. Okay. So, first of previous should be pointing at a temp. This line. First of previous should be pointing at temp. And this is your temp node. So, this part, temp of next should be pointing at first. Okay. And this line will no longer be existent. So, first will now be pointing at temp. Those are the three lines I have written over here. Temp of next is first. First of previous is temp. And temp itself becomes a now new first node. Okay. Take a moment and read the information. So, yeah. Insertion at the end. Let me keep the uh, comments also. Okay, so I will input the details using the read function. Then if it is null, then the only node becomes your first and end. Otherwise, end insertion. Okay, so end insertion. And this is your end node. Now, I want to insert the new node. I want to insert the new node temp over here. So I have to create this connection. So how do I create this connection? That is, wherever end of next will now be containing temp. And temps previous will now be containing end. And this no longer will be the end node. Temp will now become the new end. So end will now be containing like this. And return. Okay, I hope you have understood. Now the deletion. Okay, so again, deletion at the front. So and okay. So again, I have assigned this itself as temp. I have initialized it like that. Okay, over here. Next, to check for the empty list. So if first is equal to null, okay. If first is equal to null, that means your list is empty. That means if the first is not containing an address, that means if it is null, that means it is empty. Otherwise, what if there is only one node? If there is only one node, see, if there is only one node, for example, like this, then that only will be first, that only will be the end, right? So if first is equal to end, then you make sure that you let the user know that you're deleting that node. So whatever one information I will delete, what is a display. Then if I delete that very node present in the list, then first will become null and end also will become null, and you free them. Otherwise, see, deleting from the front, okay, deleting from the front. So what will happen is, okay, so this node I'm trying to delete. Okay, so if I delete this, this no longer will be the first. This no longer will be the first. This has to become the new first. But how do you make that as a new first? See, previously, before deleting, first of next was containing the information of the second node, right? First of next. So, first of next, wherever it was pointing to, make that as a new first. First of next, wherever it is pointing to, make that as a new next. And if, then delete this off. And this part. Now, this is the first, okay. So, first of previous is, sorry, first of previous will now contain the value null, because that is the very first node. So it has no previous node. So that should be null. And you free the temp and return. Okay. So take a time and go through this. Deletion from the end. Again, here, this is your end node. This is your first node. See, I've taken end and told that the end node is also the temp node. Now, if the list is empty, first is equal to null, list is empty, will be displayed. Otherwise, if there is only one node, you delete that node and first and end will be assigned to null and you free the temp. Else, you try to delete. So let's say I'm deleting from this end. Okay, I want to delete from this end. See, if I delete this end should be the last or the end node. Correct. That means the one before it. But how do I do that? How do I make the node that is previous to the last node as a new last node? So temp of, because you're also considering this one, right? So what I will do is end. This is your end node. Okay. So end of previous, wherever it was pointing to. End of previous means this part. Wherever that was pointing to, make that as a new end. And can you figure out the last one now? End of next will be containing null. And free time. Return. Okay. That is how it works. Let me erase so that you can go through the information. Now, the main program. So, end choice, while one. So, you will be given the options. Then you choose the option over here, scanf, %d, and of choice. Then case 1 means create. Case 2 means display. Case 3 means insertion at the front, insertion at the end, deletion from the front, deletion from the end, return. Otherwise, anything other than that will be called default, invalid choice. Okay. This is how the program logic has been designed. Okay. That's all for the video. I hope you have understood. So thank you so much.